Hello students, for the solving of DC networks after the superposition theorem, today in this video I am discussing about the Thevenin theorem. Students, with the help of Thevenin theorem we can make problem easy. It means that we are going to solve problems in a very easy way and we can save time also. Now, what is Thevenin theorem? What is the statement of Thevenin theorem? According to this theorem, a linear DC network is reduced into a simple circuit containing VTH, RTH and RL in series. What is VTH? VTH is the open circuit voltage or Thevenin equivalent voltage. RTH is the Thevenin equivalent resistance. RL is load resistor. For the calculation of VTH, first of all, remove load resistor and calculate voltage across the terminal at which load was connected. That voltage is known as the open circuit voltage or Thevenin equivalent voltage. Calculation of RTH. First of all, you remove the load and viewed from the load side, right? And all the ideal voltage sources are short circuited. All the ideal current sources are open circuited. If they are real or practical, then they are replaced with their internal resistances. Then whatever the resistance across these two terminals is known as the RTH. Now finally make a simple circuit containing VTH, RTH and RL and then calculate the current in the load resistor. Formula: current is equal to VTH divided by RTH plus RL. For in detail, see the board. Students, as per the statement, I am drawing a circuit, DC circuit, and solve it with the help of Thevenin theorem. Here, a DC circuit in which there is a voltage source having voltage E and resistances R1, R2, R3 and a load resistor connected in between points A and B. It is RL, right? Thevenin theorem. Thevenin theorem. Now I am resolving this circuit into a simple circuit that is known as the Thevenin equivalent circuit. This is the equivalent circuit containing three components: VTH, RTH and RL. B point RL. So this will be the equivalent circuit of this circuit. This circuit is known as the Thevenin equivalent circuit. In this circuit, there are three components. One is the VTH, RTH and RL. Right? Now our task is how to calculate VTH and how to calculate RTH. So for the calculation of VTH, see, for VTH, Thevenin equivalent voltage, how to calculate it? So I am drawing a circuit containing resistances R1, R2, voltage source E and third resistance R3. This is the point A and point B. According to the statement, I removed load resistor, right? And going to calculate open circuit voltage, or is a potential difference between point A and B. This potential difference is nothing but Thevenin equivalent voltage, open circuit voltage, right? Okay. This resistance R2 is an open circuit. no current will flow through this circuit, right? This one is a closed loop. It means that current is flowing in this loop. Say the current is I1. So the value of the I1 is given by voltage divided by resistances. Voltage is E and resistances are R1 plus R3. These R1 and R3 is connected in series, right? So this will be the value of current passing through this circuit. Now VTH is nothing but current I1 passing through the R3 into resistance R3. So this is called VTH, right? Now put the value of I1, this one, yes, VTH is equal to E upon R1 plus R3 into R3. That's why the value of the VTH is E upon R1 plus R3 into R3. Whatever the value of VTH, we are going to put this value over here in this circuit, right? Now the next one is RTH. For the value of RTH, now for RTH, follow the process of Thevenin theorem. I am repeating over here what is the procedure, right? First of all, remove load resistor, right? All the voltage sources are short circuited and current sources are open circuited if they are ideal, right? Here is a voltage source, okay, that's why it is short circuited. Now resistances are R1, R2, R1, R2, and this one is the third resistance R3, and this is point A and B, and load is removed, right? And we are going to view it from the load side. Whatever the equivalent resistance between these 2 points is known as the Thevenin equivalent resistor. How to calculate? Yes, according to the circuit, this is very simple. R1 and R3, these two are connected in parallel, and this combination is in series with R2. So the value of RTH is nothing but R2 plus parallel combination of R1 and R3, right? After that, it is R2 plus R1 R3 divided by R1 plus R3, it's your RTH. See, RTH is nothing but R2 plus parallel combination of R1 and R3 for this particular circuit, right? This value we are going to put over here and calculate current IRL. This is the current passing through the load resistor. Yes, it is nothing but VTH divided by RTH plus RL. So this is the required current passing through the load resistor, right? The value of IRL is VTH upon RTH plus RL. This current is passing through the load resistor by this circuit. So this is all about the Thevenin theorem, right? Now I am going to take an example, a very simple example based on Thevenin theorem. I am going to calculate current through the load resistor with the help of Thevenin theorem, right? For the calculation of the current, first of all, I draw an equivalent circuit containing VTH, RTH and RL, right? RL is connected in between point A and B. This is RL, it's your RTH, right? Now, first of all, you calculate VTH, then after RTH. For VTH, right? How can you calculate it? Draw a circuit containing 40 volt source and resistances R1, R2 and R3. R1, R2 and R3. Clear? Right? Okay. This 10 ohm is an open circuit, right? This 10 ohm and 10 ohm is connected in closed circuit. So the value of the current I1 is nothing but voltage source divided by 10 plus 10, it becomes 40 upon 20, that is 2 ampere. 2 ampere is the current passing through in this loop, right? This 10 and this 10 belongs to this one and this one. These two are connected in series, right? Now the VTH, that is open circuit voltage, is nothing but current I1 into 10. Whatever the voltage across this 10 ohm is nothing but VTH. So I1 is 2 into 10, it becomes 20 volts. VTH is nothing but 20 volts. This one is equal to 20 volt. For RTH, how can you calculate RTH? I am repeating, right? Whatever the process to calculate the RTH. All the voltage sources are short circuited, all the current sources are open circuited, and load is removed, right? Then equivalent resistance between point A and B is the RTH, right? For the calculation of RTH, I am drawing the circuit. Here the voltage source, it is short circuited, and resistances are 10 ohm, 10 ohm and 10 ohm, right? This is the point A and B. Load is removed over here and we are going to view it from the load side, right? See the circuit diagram very carefully. How can you calculate RTH? See, this 10 ohm and this 10 ohm are connected in parallel, and this combination is in series with this 10 ohm resistor. That's why the value of the RTH is 10, this one, plus parallel combination of this 10 and this 10. It becomes 10 plus 5, so it is 15 ohm, right? RTH is nothing but 15 ohm. This one. Now current IRL, current through the load resistor, is nothing but VTH upon RTH plus RL. It becomes 20 divided by 15 plus 20, 20 divided by 35, that is 4 upon 7 ampere. This is the current through the load resistor, right? Here the current is 4 upon 7 ampere, which is the current passing through the load resistor by the source 40 volt, which is connected in this circuit. Is it clear? Okay. Now I am taking another example related to the Thevenin theorem. Over here, it is a DC circuit. Here, the value of the load resistor is 6 ohm, which is connected across A and B, and I am going to calculate the current in the load resistor with the help of Thevenin theorem, right? That's why, first of all, I reduce it into an equivalent circuit diagram containing VTH, RTH and RL, right? The value of the RL is 6 ohm, which is connected in between points A and B, and it's your RTH. Is it clear? Okay. For this equivalent circuit diagram, I want to calculate VTH and RTH. First of all, I am going to calculate RTH, right? For RTH, what is the procedure? All the voltage sources are short circuited and we remove the load resistor, then this circuit become like this. This is the point A. Here the source is short circuited. Here another voltage source is also short circuited. This is the point B, and load is removed. This value is 5 ohm and this value is 4 ohm, and we are going to view it from the load side. So for this particular circuit, this 5 ohm and 4 ohm become parallel to each other, right? Across the point A and B, this 5 and 4 are in parallel. So the value of the RTH is equal to 5 in parallel with 4, that is 5 into 4 divided by 5 plus 4, it becomes 20 divided by 9, that is 2.22 ohm, right? So it is 2.22. Now for the calculation of VTH, yes, for VTH, we remove the load resistor and the remaining circuit is like this. It is 4.5. Three volt. This is a point A, another point B. This one is 5 ohm and 4 ohm, right? Load is removed. Now, whatever the voltage across the point A and B, this one, that is known as the VTH, right? So this is a closed circuit. Let us consider current I is flowing in this circuit. So I into 5, it is a drop. Now 4 into I minus 3 plus 4.5 equal to 0. It becomes 9I, that is equal to minus 1.5. Thus whether I is equal to 1.5 divided by 9 ampere. So the value of the VTH is equal to 4.5 minus this drop, that is current into 5 ohm resistor. We can also calculate VTH by this source, that is 3 plus current into 4 ohm. 4.5 minus 1.5 upon 9 into 5, 3 plus 1.5 divided by 9 into 4. Calculate it. Yes, so there are two equations by which we can calculate VTH, which is the open circuit voltage across the point A and B. After the calculation, we will get it as 3.66 volt. It is also 3.66 volt, right? Either you can calculate by this one or you can calculate by this one. The voltage is 3.66, this one. VTH is 3.66, right? So the current passing through the load resistor is IL. IL is given by VTH upon RTH plus RL, right? Now put the value, that is 3.66, sorry, it is 2.22 plus 6. 3.66 divided by 8.22. IL, current in the load resistor. It is 0.446 ampere. This is the desired current passing through the load resistor in 6 ohm resistor, right, for this particular circuit. Yes, after this circuit, I am going to solve another example based on Thevenin theorem. Yes, this is another example. Here the value of the load resistor is 2 ohm, and I am going to calculate the current in the load resistor with the help of Thevenin theorem. Here two sources are here. One of them is current source and second one is voltage source. current source having the value of 7 ampere and voltage source as a 12 volt. Right? It's a very interesting example. Okay, according to the Thevenin theorem, I'm going to draw an equivalent circuit containing VTH, RTH and RL in the circuit. Right? Okay, now our task is to calculate VTH and RTH. In this series, now I am calculating RTH first. For RTH, right? So what is the procedure? Procedure is that open the current source and short circuit the voltage sources and remove the load and view from the load side. That's why this circuit become like this. Point A and B, as load is removed and current source is open circuited and voltage source having the voltage 12 volt is short circuited. This is short circuited and circuit is like this, 10 ohm and 6 ohm. Any doubt? Right? And I'm going to view from this side. It's your RTH. For this particular, this 6 ohm and 10 ohm, these two are in parallel. And this parallel combination is in series with 5 ohm. Right? That's why RTH is nothing but 5 plus 10 and 6 are in parallel. It becomes 5 plus 10 into 6 divided by 16, that is 5 plus 3.75, it becomes 8.75 ohm. For VTH, right? How can you calculate? Remove the load resistor. Okay, this is the point A and this is the point B. Here load is removed and rest are 6 ohm having the voltage source 12 volt. Here is the resistance 10 ohm like this. And now I am going to convert this current source as a voltage source. There is a concept to convert the current source into the voltage source. If we multiply 7 with 5, it becomes 35 volt. Right? Then this current source become a voltage source. Direction of current is in upward direction, so it is positive and it is negative. And this resistance come in series with the voltage source. So this be the picture, and this be the picture when we are going to calculate VTH. VTH is the voltage across the point A and B. Is it clear? Okay. Right? See, this one is a closed circuit, so current will flow in this direction. Say it is I1. Okay, so in this circuit, now first of all I calculate I1, that is 12 divided by 6 plus 10. See very carefully, this 10 and this 6 are in series. So it is 12 divided by 10 plus 6, that is 16. 12 divided by 16 ampere. If this current is multiplied by 10 ohm resistor, then it becomes voltage across B and this point, right? That is the voltage at point B is nothing but I1 current into 10 ohm. That is 12 upon 16 into 10 volts. So the value of the VTH is 35 minus this voltage at point B. 35 minus 120 divided by 16. After the calculation, it is 27.5 volt. Yes, this example is interesting. Why it is interesting? Because here we use a concept how to convert current source into a voltage source. Then after we are going to calculate the value of VTH. Okay, so this one is VTH, this one is RTH, RL is here. So we can calculate easily load current. IL. What is the load current? VTH, that is 27 point. Okay, we will write first formula. VTH, RTH plus RL. Now, it is 27.5 upon 8.75 plus 2. Yes, this one 2. Load resistor. 27.5 divided by 10.75. So the value of the load current is 2.56 ampere. Now I am taking another example. In between point A and B, load resistor is connected having the value of 1 ohm. Our task is to calculate the current in the 1 ohm resistor with the help of Thevenin theorem. Right? This DC circuit contains 3 sources. One is voltage source and other 2 are current sources. Voltage source have the value of the 4 volt and current sources 1 ampere and 3 amperes. Right? Okay. To solve this problem with the help of Thevenin theorem, first of all I am going to draw equivalent circuit diagram containing VTH, RTH and RL as it is shown in equivalent circuit diagram, and the value of the RL is 1 ohm. Right? Now our task is to calculate RTH and VTH. Right? So first of all, RTH. See, for RTH, what is the procedure? Same. All the current sources are open circuited, all the voltage sources are short circuited, and load is removed. And it should be viewed from the load side. Then it becomes, this one is the voltage source, so it is short circuited. Current sources are open circuited. This is the point A. And this one is the point B. This one is 2 ohm, this one is 3. Right? That's why the resistance across point A and B is nothing but RTH. How can you calculate RTH? Yes. See the circuit diagram very carefully. Here, this 3 ohm is in open circuit. So the value of the RTH is nothing but 2 ohm only. The value of RTH over here, it is only 2 ohm. Is it clear or not? See, this 3 ohm is in open circuit. Right? So the resistance in between point A and B is only 2 ohm. Now for the calculation of VTH. Yes, I am going to draw the circuit. Voltage source having the voltage 4 volt and resistances are 2 ohm, 3 ohm. This is the point A. Here the current source having the value of 3 ampere and load is removed. Load is removed, right? And 1 ampere current source is here, like Now, what about the voltage across point A and B? This one is VTH. How can you calculate? See, this one is 3 ampere. Yes, 3 ampere. Here current is 1 ampere. Yes, it is 1 ampere. This 3 and 1 is going to pass through this branch. So the current in this branch is 4 ampere, which is opposite to the direction of this voltage source, plus minus. So the value of VTH is 4 plus 2 into 4, because we are going to calculate voltage at point A and B. It becomes 4 plus 8, it is 12 volt. Right? Or in other words, see this one, 4 into 2 plus 4 minus VTH equal to 0. Once again, we will get the same value, that is 12 volt. So this be the Thevenin equivalent voltage. Now, for the IL, VTH, RTH plus RL, it is 12 divided by 2 plus 1, 12 divided by 3. So it is 4 ampere. Current passing through the load is 4 ampere by the 3 sources. One is voltage source, other 2 are current sources having the value of 4 volt, 1 ampere, 3 ampere. So the current passing through the branch A and B or 1 ohm resistor is 4 ampere.
Students, now I am giving some assignment based on Thevenin theorem. You know about the coin, there are 2 faces. Same thing over here. One face belongs to the classwork and second face belongs to the home assignment. Home assignment is the complementary part of the classwork. Now see the question number 1. Why do we use network theorem and techniques to solve the electrical circuits? And the second, what are the advantages of Thevenin theorem? Third, write the statement of Thevenin theorem. And the last one, that is the fourth one, find the Thevenin equivalent circuit to the left portion of the terminal A and B for the given figure. This is the answer of the question number 4.